Next, we come to another law in probability, which is called multiplication law. So again, like additional law, when we talk about mutually exclusive events, now in multiplication law, there is another kind of events called independent events. If the probability of two events P and F is equal to PE times PF individually, then we call them independent to each other. It is also called the multiplication law of probability for individual events. So the number of events is not limited, so you can talk about lots of events like E1, E2 until En. We will take example 22 as an example. Now you are doing two actions. One is called tossing a coin as well as throwing a dice, respectively. And you want to get the following results. Coin shows a tail, while dice shows an even number. So probably they should be independent events, right? Because they are talking about two situations. So that's why we have the required probability as follow, which is equal to getting a coin to be a tail is 1/2, while getting an even number for dice will be 3/6. And because they are independent events, so you multiply them together. Multiply in probability normally it means that you're doing like two actions, you're doing two things together, and finally you'll get the result is 1/4. Another situation of independent events, like you can be throwing a dice twice, and of course it won't depend to each other. And like, so part A, the required probability will be if both of them show odd, so it's 3/6 and also 3/6. You're doing the action twice, throw the dice twice, so that's why we multiply them together, and finally give you 1/4. If you want to get multiple of 3 in part B, so the question is more or less the same. So this time multiple of 3 includes 3 and 6, so that's why 2/6 will be the probability of each event. And the second time the dice is thrown, so it gives you 2/6 as the outcome as well. And finally, it gives you the answer of 1/9. Another question I pick up in the examination paper will be example 25. And there are two people, Peter and May, going to throw a dart. So Peter would be, I like to draw like tree diagram or diagram to the way hitting the target is 0.2, so that's why not hitting is 0.8. May, hitting target will be 0.3, that means not hitting will be 0.7. So they won't affect each other, hopefully, as mentioned in the question. When you are talking about at least one dart hitting the target, that means either one of them hitting the target, then that means you are talking about, you count it very carefully. Peter hits, May hit, one case, or one of them hits. Peter hit, May not hit, Peter not hit, and May hit. So there are totally 3 situations in order to get the result. And then so now let's list out the possible outcomes right now. First case is 0.2 times 0.3. Second case, 0.2 times 0.7. Third case, 0.8 and also 0.3. So there are 3 possibilities over there, and each situation we multiply them together because you're doing 2 actions, Peter X and also May X. But at last we will add them together because the situation only happened once, either the first case, second case, or the third case. And then let's see whether you can clear enough for you to justify or to understand when you use multiply and when you use add. And finally, you get the result 0.44, which is the answer for B. In our case, we can use multiplication law. In this way, will be you're talking about 3 in this paper question. So it's all different. Okay, I would like to highlight keywords all different. That means we should also exclude a case like 1, 1, 2 is not our outcomes because 2 of them are the same. So the 3 numbers should be different to each other. And so what can we do? Okay, the dice is thrown 3 times. Fair die, you remember? So that's why each number, the possibilities will be 1/6 as its occurrence. And then next, 3 dice, it gives you 666, right? Okay, now When you talk about all different that means it's like 3 numbers, 3 dice showing 3 different numbers. We can use the idea of counting as follow. First number, you can have any choice, 6 choices in total. The first die show 1 number, so the second die can't show this number. So that's why there's 1 favorable outcome less. There are only 5 now. So when the first 2 dice show 2 different numbers, so the last dice there are only 4 possibilities to give you another different number. So that's why on top is 6, 5, and 4, which gives you the answer 5/9. If you check the calculator, it gives you the answer A.